Hello, my precious friends. I really hope that you are doing great. Welcome to today's class. It is our second and last lesson on the fourth topic of Form 4, which is called electromagnetic spectrum. As usual, let me commence by giving the quote of the day, which states that we may not have the ability to control every situation, but we have the ability to control our attitude towards every situation. We shall discuss that quote at the end of our class today. So remember from our previous class, we did discuss about electromagnetic waves. We also gave examples of electromagnetic waves and also looked at what we call an electromagnetic spectrum. So today we are looking at detection, source, and application of electromagnetic waves or electromagnetic radiations in real life situation. So we are going to start by the gamma rays. So the gamma rays, the source, that is where you obtain the gamma rays. They are obtained from radioactive substances. That is, they result from the energy changes occurring in the nuclei of the radioactive atoms. So remember, we shall discuss more about radioactive substances in the second last topic of Form 4, which is called radioactivity. So detectors of the gamma rays, so they are detected by photographic plate. They can also be detected by what we call the GMT or the Gauger-Muller tube, which we shall also discuss further under the second last topic of Form 4, which is called radioactivity. Then the application of gamma rays in real life situation, one is that the gamma rays are used in medicine for sterilizing medical equipment, killing cancerous and other malignant growth in the body since they kill bacteria. So remember, we shall see that is under radioactivity that gamma rays, they usually have the high penetrating power. They can penetrate through most materials. So because of their high penetrating power, they are used in medicine for sterilizing medical equipment because they are able to kill the bacteria within those particular medical equipments before they are used in surgery, maybe for another patient. Then they can also kill cancerous and other malignant growth. So malignant growth, these are simply growth that are undesired in the body, or growth that are simply not required in the body, which result from cell division. So cell division can lead to a growth of some body parts which is not necessary. So remember, this growth can lead to even what we call tumor. So the growth in the body, since they can kill bacteria. The other application of the gamma rays in real life situation is that they are used in industries to detect flaws in metals. So remember, they have a very high penetrating power, therefore they can penetrate through metals and detect where we have faults or flaws within that particular metal. Then our second radiation is what we call the X-rays. So the production or the source of X-rays, they are produced in X-ray tubes. Again, we shall discuss more about X-rays in a given chapter, still in this Form 4, which is called X-rays. So we shall discuss the production of X-rays and everything. So X-rays are produced in X-ray tubes as a result of orbital electron jumps, or the X-rays can also be produced when a beam of fast-moving electrons hit a metal target. The metal target is usually tungsten. We shall discuss more about that when we shall be looking at X-rays as a topic. Then the detectors for X-rays, one is the fluorescent screen. A fluorescent screen is simply a screen whereby when you, that is when X-rays are irradiated on it, or when they are focused on the fluorescent screen, once X-rays reach that fluorescent screen, it actually glows or it fluoresces. The other detector of X-ray is what we call the photographic film, which can also maybe show some pictures of the X-rays or whichever maybe image that you want to obtain. Maybe when you are taking an X-ray photograph or in radiography. Then applications of X-rays in real life situation, they are used to take X-ray photographs, which we are calling radiography, used to identify and locate internal body fractures or foreign objects within the body. Yeah, you might have maybe swallowed a metallic object accidentally. So to identify exactly where that metallic object is located within the body, we can use X-rays to actually detect where those undesired objects or foreign objects within the body are located. Remember, X-rays also have a high penetrating power. They can penetrate through the body and then of course form an image on photographic films to show where the fractures within your body are, or where the foreign objects are, so that the doctors can actually perform an operation on a specific body part. Then X-rays are also used in cancer therapy, since the radiation is capable of killing malignant tissues. These are simply tissues that grow in undesired way. That is, they are not desired within the body, but they can grow as a result of maybe cell mutation. So they can also lead to tumor. Then X-rays are also used in crystallography. That is, crystallography, simply the study of the crystal lattice. So it is used to detect flaws in metals and forgeries in art. Yeah, because again they have a high penetrating power. Then the last use of X-rays, they are used in controlling pests and germs by irradiation. So whenever X-rays are irradiated or directed to maybe crops which have the pests and the germs, because of the high penetrating power of those X-rays and because they are also strong, they are able to kill those pests and germs. Yeah. Next, the other type of radiation is ultraviolet radiation, also called ultraviolet rays. So their sources, one, the main source is the sun. We have sparks and the mercury vapor lamps. So detectors of ultraviolet radiations or ultraviolet rays, one is the photographic films, two is the photocells, then we have the fluorescent materials, for example, quinine sulfate and the pepper are lightly smeared with petroleum jelly, such as the Vaseline. Applications of ultraviolet radiations in real life situation, they are used to detect forgeries, for example, in bank notes. Yeah, when you want to identify whether a banknote is original or fake, you simply hold it against the sun, or you hold it against the ultraviolet radiation. Then when some certain features are visible, you'll be able to identify whether that banknote is original or fake. The other application of ultraviolet radiation is that it is a source of vitamin D. It is also used to kill bacteria, that is in skin treatment. It is also used to detect freshness of an egg. Yeah, when you hold the egg against the sun, you are able, or against ultraviolet radiations, you are able to see, that is the internal body parts, and which will help you to determine whether that particular egg is fresh or not. Then it is also used in spectroscopy and mineral analysis. Then lastly, it is used with photocells. The other type of radiation is the visible light. Of course, the main source is the sun. Other sources include hot objects, lamps, and laser beams. Detectors of visible light, one, we have the eye, we have photographic film, and of course the photocell. Applications of visible light, one is in ordinary photography, two, it enables the eye to see, then three, it is also used in photosynthesis. That is a process by which plants actually manufacture their own food, of course in the presence of visible light. Then they are also used in optical fibers and in light amplification by the stimulated emission of radiations, which is called the laser beams. Then the other type of radiation is infrared radiation, also called infrared rays. The main source is the sun, fire, and hot bodies. Detectors include thermometer with a blackened bulb. The other detector of infrared radiation is the thermopile. Then the last application, that is the last detector of infrared radiation, is an instrument called a bolometer. A bolometer is simply an instrument that is used to measure heat radiation. Then application of infrared radiations in real life situation, one is that we have what we call the infrared photography. Then it is also because of the heating effect that is produced by infrared radiation. The infrared radiation can actually be used in cooking food, they can be used in heating, they can also be used in drying of grains. Remember, infrared radiations, they have a heating effect. They can also be used in heat-seeking missiles. Then the other type of radiation is microwaves. So their source is in magnetrons, that is in microwave ovens or with a MESA. Detectors include the solid state diodes, and we also have the crystal detectors. Applications of microwaves in real life situation: one is that they are used for cooking, of course, in microwave ovens. They are also used in satellite communication. They are also used in radio detection and ranging communication, which is abbreviated as radar communication. Then the last type of radiation is the radio waves. They are produced by oscillating electrical circuits and transmitted by antenna, or what we call the aerials. Detection: they are detected by aerials. They are also detected by diodes. They are also detected by earphones, which are in an electric circuits. Then application of the radio waves include radio and ground communication. Then we also look at the greenhouse effect. So this is how the greenhouse effect actually takes place. So this is our glass plastic panel. We have the sun, which is the source of the infrared rays. So short wavelength infrared rays and light rays from the sun can pass through the glass or plastic panel of the greenhouse. So the short infrared rays, and of course from that is and light, they originate from the sun. They can easily pass through the glass or the plastic panel of this particular greenhouse. Once they pass and they go to the plants, actually the plants will absorb those short wavelength infrared radiations. And when the plants absorb them, they actually heat them, hence converting them from short wavelength to, of course, a larger wavelength. So short wavelength infrared radiations and light rays from the sun can pass through the glass or the plastic panel of the greenhouse and are absorbed by the soil and plants. So this raises their temperature. So when the soil and plants absorb those infrared rays from the sun, they actually increase their temperature. Hence, the soil and the plant in turn emit longer wavelength. Remember, when you increase the temperature of the infrared rays, actually you are increasing their wavelength will actually increase, because you have simply increased the kinetic energy of the molecule. So the wavelength will be far much longer. So the soil and the plants in turn will emit longer wavelength infrared, of course, rays. So these are the longer wavelength infrared rays which have been emitted by the plants and soil, the ones that are in color purple, so which cannot penetrate the glass. So the long wavelength infrared rays that have been emitted by the plants and of course by the soil, they cannot penetrate through this particular glass, and that is why they are trapped within that particular glass or the plastic panel. So the soil and the plants in turn emit longer wavelength infrared which cannot penetrate the glass. So the inside of the greenhouse thus remains hot, because the infrared rays that went into that particular greenhouse, once the plants and the soil absorb them, they increase their temperature. When their temperature increases, their wavelength will increase. Therefore, they will not be able to pass through this particular the glass or the plastic panel. So when they are not able to pass through the glass or the plastic panel, it simply means that those infrared rays will actually be retained within that particular greenhouse, which increases the temperature of the inside of the greenhouse. And of course, the higher temperature is conducive for the plants which are planted within that particular greenhouse. Lastly, we look at radio detection and ranging communication, what we call the radar communication. So we are saying that microwaves, which have much shorter wavelength, are used for radar communication or the radio detection and ranging communication. So this radar communication is useful in locating the positions of aeroplane and ships. So you can see we are trying to locate this particular aeroplane using the radio detection and ranging communication, or what we call the radar communication. Then of course we have the transmission of radio waves, whereby we are saying that medium and short wavelength radio waves are used in radio transmission signals. So we have the amplitude modulation, what is called the AM radio transmission. They have longer range because of the reflection by the ionosphere. So you can see we have, that is our radio waves which are being emanated from the transmitter. So the transmitter can be, for example, a radio station or maybe a television station. So it transmits the radio waves, then of course they go through the ionosphere, then in the ionosphere they are reflected directly to the receiver. So we are saying that the amplitude modulation or the AM. So AM in full simply means amplitude modulation. So the amplitude modulation radio transmission, they have longer range because of the reflection in the ionosphere. Remember, ionosphere from geography, it is simply the outer region of the Earth's atmosphere, which usually contains a high concentration of free electrons. Then television and frequency modulation. So that is FM in full is the frequency modulation. So television and frequency modulation, that is the FM radio transmissions, are received at shorter wavelength than the normal radio broadcasts. So remember, the normal radio broadcasts, they go through the AM, that is the amplitude modulation. But when we talk of the television and frequency modulation, that is the FM, they are transmitted. That is, the FM radio transmissions are received at shorter wavelength. You can see this particular distance is shorter as compared to that of the AM, that is that of the amplitude modulation. So from the transmitter directly to the recipient, so remember the transmitter can be maybe a television station or a radio station, then the receiver is the aerial of your television or the radio at that particular home. So the receivers are the aerials and the transmitters, of course, is either television or a radio station. So television and frequency modulation, that is television and frequency modulation radio transmission, are received at shorter wavelength than the normal radio broadcasts. So very high frequency, what we call the VHF transmissions used in television and FM radios, are transmitted over short distances and received directly from the transmission. So you can see they are being taken from the transmitter, that is the radio or the television station, directly to the recipient through the aerials of either your television or radio at home. That is whenever you are listening maybe to your favorite station. So these are direct space wave, that is the FM or the frequency modulation, and also the television. Then this is of course the Earth surface. Then some radio, that is some microwaves, can also be transmitted through satellites, then back to the receiver. Then we look at a microwave cooker, whereby you are saying that microwaves can be used for cooking. So the microwaves, they have what we call the magnetrons, whose role is to produce the microwaves. So the magnetrons produce the microwaves at a frequency of about 2500 megahertz. So these are the magnetrons that produce the microwaves at a higher frequency of about 2500 megahertz. Then these waves, that is the microwaves, are directed to the rotating metal stirrer. So you can see they are being directed to this rotating metal stirrer. So it is usually in rotating position, which reflects them to different parts of the oven. So once the magnetrons produce the microwaves, they are simply directed to the rotating metal stirrer, which reflects these microwaves to the oven that is within that particular microwave cooker. So in the oven, this is where we have food on rotating turntable. So within the oven, we have the food that is placed on a rotating turntable. So in the oven, food is placed on a turntable where it absorbs the microwaves evenly. So once those microwaves are absorbed, the microwaves, they heat up the water and the fat molecules in the food, hence cooking the food up. So how it works, we simply have the magnetrons which produce the microwaves, of course, when it is switched on. So when you switch on using the control knob, that is when the microwave is switched on, the magnetrons produce the microwaves which are directed to the metal stirrer, which reflects those microwaves to the food that is placed, that is which reflects the microwaves into the oven. Now within the oven we have a turntable where food is placed, and of course the turntable is usually rotating. So when the food receives those microwaves from the metal stirrer, it absorbs those particular microwaves. So when the food absorbs the microwaves, they heat up the water and the fat molecules in the food, hence cooking the food. Then you can see we have the window, that is the window with the fine wire mesh. The question is, what is the role of this particular fine wire mesh in the window? So the wire mesh on the door reflect the microwave back inside. So its purpose is to reflect the microwaves back into the oven so that it can be used to heat up, so that it does not get reflected to the outer parts of that particular microwave. So the wire mesh on the door reflects the microwaves back inside. Then the device is switched off before opening the door. So before you switch off the device or the microwave cooker, you have to ensure that you switch off first before you open the door. Otherwise, if you open the door before you switch off, it simply means that the microwaves will actually be lost to the outside part, and therefore they won't be used in cooking your food effectively. Then we look at the hazards of some of the electromagnetic waves, whereby you are saying that the penetrating power of electromagnetic waves can cause damage when not controlled. For example, ultraviolet rays, X-rays, and the gamma rays, they have a very high penetrating power. Therefore, they carry high energy when absorbed into the body, and in large doses. Therefore, they may cause body cells, that is, they may cause damage to the body cells, skin burns, or even affect the eyes. So this widespread damage of the cells may be fatal. Then there are also delayed effects of the radiations, like, for example, they can cause cancer, they can cause leukemia, and also hereditary defects in children. So these dangers which are posed by these radiations can be minimized by reducing their dosage, by shielding ourselves from the sources of those rays, by keeping safe distance from their sources, and also by minimizing exposure time. We shall discuss more about these hazards, that is when we'll be looking at radioactivity. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that we may not have the ability to control every situation, but we have the ability to control our attitude towards every situation. So our mind is naturally programmed by the content we feed it to magnify negativity in every situation and ignore all the positive things in the situations we face in life. We must therefore be careful with the type of information we feed our mind, because that information affects the way we think. And remember, your thought will always determine your attitude, and your thoughts will also determine the kind of decisions that you are going to make in life. And remember, decisions or the choices, they have consequences which can be positive or negative depending on the type of the decision. And lastly, recall that your attitude will always be directly proportional to your altitude. Similarly, we cannot direct the wind, but we can adjust the sails. That is, we cannot control some situations, but at least we can control ourselves, the way we react to those particular situations. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get notified. Until next time, this is Kind Tuition Academy. Thank you very much. So I expect us to start the next topic in our next lesson, of course, which will be electromagnetic induction. Thank you very much for the continued support. I really appreciate for your positive comments. Until next time, this is Kind Tuition Academy.